Okay, we are in business. We got 6 people with us. Good morning, you guys. All right, I'm going to share my screen so y'all can see the screen. Cool. Okay, so if you haven't done your attendance question, if you are Zooming live with us, make sure you do your attendance question. Everyone needs to do that every day. All right, so we're going to go to modules and we're going to take a look at your homework first. So get out your book or your homework, whatever you have from yesterday. That should already be submitted to me. And so I have the key posted for you guys so that we can take a look at that. In Wednesday, you'll see lesson, I need to make it published. Okay, it's published, so now you can look at that. So that is lesson 3-1 homework key. All right, so your homework last night was on, what page is this? 28, page 28, lesson 3-1. The problems were 8 through 12. Okay, does anybody have questions on those that we need to? You didn't bring your book? Okay. Do you remember which one you had a question on? If you're virtual and you have a question, you can just unmute yourself, jump in. So number 8 just said identify the property that justifies the statement. Okay, they add 3, right? So that would be the addition property of equality. Complete the prove statement and write a 2-column proof. That's over here on number 9. There's our prove statement, x equals 5, which is really how I want you to write them. I don't want you to write it as 5 equals x. I want it to be x equals 5. And then you can see that 2-column proof right here over to the left. Number 10 says, explain why line segment is considered a defined term in geometry. Well, it's a defined term because it uses an undefined term, line, to describe it. They said number 10, line segment is a defined term because it can be defined in terms of the undefined terms point and line. A line segment is part of a line between 2 points on a line. Number 11, complete the proof statement. Write a 2-column proof for the equation. You can see that there at the bottom. N equals 12 is what your proof statement is, and then there is an example of the 2-column proof. Number 12 says, suppose you are given that A equals B plus 2 and B plus 2 equals 5. What can you prove using these statements and the transitive property? Remember, the transitive property is the one that tells you, we didn't talk about this too much in class, but it says if A equals B and B equals C, then A equals C. So in this case, our A is A, but B is B plus 2. So then B plus 2 equals C. So A is A, C is 5. So A equals 5. That's what the transitive property says. All right, so that's your homework. Hopefully that did not take you very long. Remember that you are not just submitting homework, you are submitting homework and notes. So even though you guys were virtual yesterday, you need to get the notes and the homework submitted, okay? Any questions about any of that? Perfect. Okay, so the next thing that we're going to do is flip over in our book to our next lesson, which is 3-2. That is going to be on page 29. Page 29. Nope, that's not the right page. What page am I looking for, y'all? Page 36? I'm in the wrong textbook. This is Algebra 2. Okay, so yes, it is. It is page 29. All right, so if we look at our learning targets and what they're asking us to do, it says identify. So we're going to be identifying the hypotenuse and the conclusion of a conditional statement. So hypothesis, conclusion. And then it also says give the counter examples for false conditional statements. Okay, so right now a lot of that probably doesn't mean a whole lot to you, but hopefully as we get through this lesson, you'll understand exactly what they're wanting us to accomplish with dealing with these conditional statements. We will be talking about conditional statements for the remainder of the year. Okay, so this is like something that you're going to learn. You're going to add this idea to your bank of what you know, and then we will refer back to it several times throughout the year. Okay. All right. So if we look at that first paragraph, it says rules of logical reasoning involve using a set of given statements along with a valid argument to reach a conclusion. Statements to be proven are often written in if-then form. An if-then statement is called a conditional statement. In such statements, the if clause is the hypothesis and the then clause is the conclusion. So what we're going to be working with is if-then. If it is raining outside, then it is cloudy, wet. I don't know, something like that. An if-then statement, okay? So we're going to see lots of examples of that. So, okay, if we look off to the side, this is important too because you'll see this quite often. It says the letters P and Q are often used to represent the hypothesis and the conclusion. Respectively, in the conditional statement, the basic form of an if-then statement would be if P, then Q. Okay, so if P, then Q, which means that P is your hypothesis and Q is your conclusion. Okay, so they will refer to it as if P, then Q throughout the year. So you've got to make sure you know P's and Q's and what they represent. So here's our first example. If we look at example A, the conditional statement says if 3, open parentheses, x plus 2, close parentheses, minus 1, equals 5x plus 11, then x equals negative 3. So this is my hypothesis. Okay, that's my if statement. My conclusion is that x equals negative 3. Okay, so it says try these A's. Use the conditional statement if x plus 7 equals 10, then x equals 3. You are going to do A, B, and C. I'm going to give you just a few minutes to do A, B, and C. All right, so what's our hypothesis? Very good. And what's the conclusion? All right, then it says state the property of equality that justifies the conclusion of the statement. What property is going to justify? How did you go from here to here? Yeah, not addition though. That's right. The subtraction property of equality. Okay, so the subtraction property is what we're going to use because we are going to subtract 7. All right, then the next says, conditional statements may not always be written in if-then form. You can restate such conditional statements in if-then form. Restate each conditional statement in if-then form. I'll go if you go. So it's not written in if-then form. So we are going to have to rewrite that. How would we rewrite that? That's right. If you go, then I'll go. If you go, then I'll go. Okay? So you've got your hypothesis is you go. The conclusion is I'll go. All right, and look, you can see it here too. You can see these different ways forms of conclusions can be written. The next one says there is smoke only if there is fire. So here's our only if. Okay, so how would we rewrite that as an if-then statement? If there is smoke, then there is fire. No. And let me tell you why. Let me write this first and I'll tell you why it cannot. Okay, what we're looking for, our goal, is to have if P, then Q. This is how we want them to be written. They want us to write them in if-then statement. So you have to identify the P and the Q, okay? So like if you look at the first one was the if statement right here in the middle, right there. I'll go if you go, so that's this one. Q if P. So that's why we swapped it around, because you want P to come first, then Q. So that's why this one got swapped around. Whereas this one is only if. So that's this only if. P was already first, Q is last. So you just keep it if the first statement, there's smoke, then Q, there's fire. Okay, so the only one that's going to be swapped around is the one that just has the if statement smushed right there in the middle. Now, look at this one. X equals 4 implies x squared equals 16. If we just look at our P's and Q's. So implies is here in the middle, which means this is P and this is Q. So we don't have to switch them up. P is first, then Q, P and Q. We're going to say if x equals 4, that's P, then x squared equals 16. That's Q. You're submitting this to me. You know that, right? Oh, I can give you a pen or a pencil. I actually have a pencil, and then you can just keep it. Coronavirus. It's going to be much easier to. You're totally fine. You're fine. My smelly Christmas stuff is melting those pencils. Tell you how long it's been since I opened that. It's yours. Merry Christmas. It smells like Christmas time, kind of peppermint. All right, are we okay with that? If P's, then Q's. This really is helpful, this little box, because it really just helps you figure out who to write first. Just remember, if they want to if then, always P, then Q. P comes first, which is your hypothesis, then Q, it is your conclusion. All right, so here we go to the next page. Page 30 says, if then statement is false if an example can be found for which a hypothesis is true and the conclusion is false. This type of example is a counter example. So what is happening with this is if you make a statement and someone can like falsify it or say, no, this is how that would be a false statement, then you have a counter example. Okay, so it says, number 2, this is a false conditional statement. If two numbers are odd, then their sum is odd. Okay, so that might be true in some cases, but we can find a counterexample. It says identify the hypothesis of the statement. So what's the hypothesis of number 2? That's right. If two numbers are odd, that is our hypothesis. That's the P of this situation. Then what's the conclusion? Their sum is odd. And to be totally honest with you guys, if is not really part of this. It's not really part of the hypothesis. It's just the if of the if and then. So it's really just two numbers are odd. Their sum is odd. Okay, so they want you to give a counter example. What is something that is going to say, nope, that's not true because here's an example where it's false. Okay, 3 plus 3 equals 6. That's a good one. 3 is odd, 6 is even. What's another one? Okay. Think of one that doesn't repeat the number. 3 plus 7. What's 3 plus 7? It's 10. Okay, so those are all good examples. There's a lot of them. Okay, so really, though, you just need one. The statement is false if there is one counterexample. Doesn't have to be that there's a ton. As long as there's one, that statement is off. Okay, it's not going to be true. You just have to give one counterexample. And they used 1 plus 3 is what the book said. 1 plus 3 is 4. Okay, so that's just another one. All right, so let's check our understanding. Okay, number 3 says, if you can find an example for which both the hypothesis and the conclusion of the conditional statement are true, is the conditional statement necessarily true? So if there's one example of it being true, does that mean it's always going to be true? No, not necessarily, okay? Because it just needs one counterexample for it to be false. So it may have an example that makes it true. It may have 10 examples that make it true. But if there's one that makes it false, then it is a false conditional statement. The book says, no, there may be other examples for which the hypothesis is true and the conclusion is false, which would make the conditional statement false. Just like what we said. Number 4, give an example of a true conditional statement that includes this hypothesis. An angle is named angle ABC. So it wants us to give a true conditional statement that goes with that. What have we learned about angles already this year? Okay, it could. That's true. Okay, what else do we know though about it factual? Like what's another fact about this, just that you know based off its name? That's exactly what I'm looking for. B would be vertex. The things that you guys said is true, but just off its name, we know that B is a vertex. So we could say if an angle is named angle ABC, then B is the vertex. Is there any counterexample of that? No. There's no other way that that is going to be proven false, because even if we did CBA, B is still going to be the vertex of that. So there's no counterexample, so that is a true conditional statement. 5 says, give an example of a true conditional statement that includes this conclusion. So here's our conclusion. The angles share a vertex. That would be your then statement. Okay, yeah. We could just go off this way is what you're thinking? Yeah. And have like F, B, G. Okay, cool. That would work. So if you could say, if the angles A, B, C and angles F, B, G are together, then the angles share a vertex. That would be good. I was thinking kind of the same thing that she was thinking. I just was thinking about adding on like D and just saying angles, if angle A, B, C and angle C, B, D are, I mean, I don't want to say together because that's not very mathy, but together, then they share a vertex. Let's see what the book says. They may have like something smart. They said if two angles are adjacent. Well, that's smart because I'm calling them together. That's the math word that I was looking for. Instead of saying together, we could say adjacent. You could just say if angle A, B, and C and angle CBD are adjacent, then they share a vertex. Leave it to the book. All right, number 6. Caesar conjectures that the quotient of any two even numbers greater than 0 is odd. Write his conditional statement. Give a counterexample to show that he is false. Okay, so we need to write our if-then statement. So for number 6, we're going to say if what? What is he saying?
If any two numbers greater than 0.
If any two even numbers greater than 0 are, what are we doing with these two things? Are divided. Then what?
Then 0, or
then the quotient will be odd. If any two numbers greater than 0 are divided, then the quotient will be odd. Now, we need a counter example. 12 divided by 2, are those even numbers greater than 0? Yes, they are supposed to have an odd quotient. Well, what's 12 divided by 2? 6. Now, do I need to come up with another example? No, you just need one example that is going to counter example that is going to prove that it's false, and that makes the whole statement false. Okay, number 7, write the definition of collinear points as a conditional statement. So first of all, I'm going to read you the definition in the back of the book. So we have our exact definition. If anytime you're looking for a glossary back here, there is a glossary. It is in English and Spanish. Okay, so don't just flip to it and be like, oh my gosh, I don't understand those words. The English words are there too. Okay, so collinear. Collinear points. The definition is points that lie on the same line. So the definition is points that lie on the same line. But they want you to write this as an if-then statement. So how would we do that? That's right. If the points lie on the same line, that's your hypothesis, then they are collinear. Okay. Questions about this lesson? That's it, y'all. Today's is just kind of a short lesson. You still have a lot of time in class, but you do have those homework problems 8 through 12 on page 31. So you can use the remainder of the class period to work on those. When you're done with that, you can just work on other classes' work or take a breath, whatever you need to do. What you got, Skylar? What's your face confused about? This is 6, and then this is 7. And this is 7. That all is number 6. Does that help? Okay, anybody on our virtual learning have questions, because we are about to be done? All right, y'all do your homework. If you have questions, email me.